Dear listeners, now let us see a detailed example of Bayes' law. In this example, uh, the statement says in the city San Francisco, the prevalence of HIV virus is 3%, and this is some historical data that we have. And from this historical data and from this information, we have to compute the probability of infection given the test is positive. So we have to compute this value given the report of a person is positive. What is the probability that he actually has HIV infection? So to compute this value, we will use Bayes' law, and according to the Bayes' law, we will write it as probability of HIV positive given test positive is equal to probability of test positive given HIV positive into probability of HIV positive whole divided by probability of test positive. So to put values in this formula, let us get information from these statements, and let's write the historical data in elaborated form. So it says the probability of HIV infection in that city is 3%, and it means 3 in the 100, so it will become 0.03. So the probability of this is the probability of having HIV infection 0.03, and the probability of having not having infection will be 1 minus 0.03, and it will become 0.97. So the next is, he says the false positive rate of the reports are 0.001. So sometime it happens that the report is positive, but actually the person doesn't have any infection. So it says false, the report is positive, but actually the report is false. So given the person has no infection, the probability of positive test is 0.001. So given that the person do not have any infection, giving HIV negative, the probability of positive report is 0.001. So if we, for the probability of test negative given HIV negative, it will be 1 minus this value, and we will get 0.999. And the next, he says that the probability of false negative means the report is negative but the report is false. So actually the person does have HIV infection, but the report is negative. So given the person has HIV positive but the report is negative, it has probability of 0.01, and for calculation of probability of test positive given HIV positive, we will subtract this value from whole probability, that is 1 minus 0.01 will be 0.99. So we have computed these values that we will use to put in this formula. So in the next we have to calculate, so this value has been computed here and this value has been computed here. So next we have to compute probability of test positive. And as you know, in previous lecture, when we discussed about the basic laws of probability, like conditional probability and probability intersection, there we discussed that if we want to find the total probability of a factor, we find all the intersection of this factor with other factors of the problem space. So in this problem space, the other factor is HIV. So probability of test positive will be probability of test positive and HIV positive plus probability of test positive and HIV negative. So we will add these two probabilities to find the total probability of test positive. And to compute this uh, computation, we will use the formula that we discussed in the previous lecture, that is probability of A and B is equal to probability of A given B into probability of B. So by putting these value in this formula, we will get this value, and similarly from this we will get this formula. And so this is the formula which will give us the total probability of test positive. And by putting the values in this formula from here, test positive, HIV positive, here it is 0.99 into probability of HIV positive, that is 0.03, plus probability of test positive given HIV negative, 0.001 into probability of HIV negative, that is 0.97. so this is the probability of test positive. So we copy it from here and we will place it here as denominator, and in the numerator we have test positive HIV positive, that is 0.99 into HIV probability of HIV positive, that is 0.03. So this is the answer of this question, that is the probability of HIV positive given the test is positive is, we can compute this equation. So that's it.